number. So this is the smallest member, and also this will always be even. M square plus 1, this is the largest member. This is what? Largest member. So which type of question you will find based on these Pythagorean triplet? Let's discuss through with an example. Suppose find members of Pythagorean triplet if its smallest member is what? Smallest member is 8. Smallest member is 8. Smallest member is given to you, and through this you have to find another members of Pythagorean triplet. I have already told you smallest member is always 2m. That means 2m is what? 8. This is given to you. So through this you can find the value of m, which is 4. M is 4. Through this value you can find other members. Other members are what? M square minus 1, which is 15, and next member is m square plus 1, which is 17. Okay, so our Pythagorean triplets are what? Pythagorean triplets are 2m, m square minus 1, m square plus 1. Okay, these are the 3 members of Pythagorean triplet. So in our example, 2m is what? 2m is 8, m square minus 1 is 15, and m square plus 1 is 17. These are the 3 members of Pythagorean triplets. If we put these 3 values in the relationship between 3 sides of right angle triangle, this will always holds true. So see how we can apply them. First of all, we will take our left hand side, which is hypotenuse square. In all the 3 sides of right angle triangle, hypotenuse is always largest one. So in these 3 members, the largest number is what? 17. So we will find 17 square, which is 289. Now we will take right hand side. Our right hand side is perpendicular square and base square. Okay. Now the other rest 2 members. The rest 2 members are 8 and 15. 64 and 225. If we add these numbers, we will get 289. So see children, our left hand side and right hand side both are same. That means with the help of these Pythagorean triplet, you can find 3 sides of right angle triangle, and right angle triangle always holds the property h square is equal to p square plus b square. That means this property always holds true in case of right angle triangle. So children, are these properties clear to you? Now let's discuss next property. Our next property is we can express squares of any number as sum of first n odd numbers. We can express square of any number as sum of first n odd number. Now let's discuss this property with the help of an example. Suppose we have to find 4 square. We have to find 4 square. 4 is any natural number. So we can express square of any natural number. Any natural number, which is 4. 4 square is what? 16. Now how we can express this 16? Since this is 4 square, that means we have to consider first 4 odd numbers. First 4 odd numbers are what? 1, 3, 5 and 7. So we can express 16 as sum of these 4 numbers. If we add these 4 numbers, we will always get 16. Now let's discuss another example. Suppose we have to find 7 square. 7 square is what? 49. 7 square is 49. Now how we can express 49? Since this is 7 square, that means we have to consider first 7 odd numbers. First 7 odd numbers are what? These are the first 7 odd numbers. So we can express 49 as sum of these odd numbers. That means if we add first 7 odd numbers, we will always get 49. So I think it is clear to you. This property is clear to you. Now let's move to another property. Another property is we can express square of any odd number. Square of any odd number. What? Odd number. As sum of 2 consecutive numbers. We can express square of any odd number as sum of 2 consecutive numbers. Now let's see this property with the help of some examples. Suppose 5. 5 is an odd number. 5 square is what? 5 square is 25. So how we can express 25? We can express 25 by n square minus 1 by 2, n square plus 1 by 2. So here n is what? N is 5 and n square is what? 25. 25 minus 1 by 2, 25 plus 1 by 2. So we will get 12 and 13. That means how we can write 25? We can express it like 12 plus 13. That means what's the property? Property was we can express square of any odd number. You have to take what? Odd number, not even number. You have to consider odd number. So you can express square of any odd number as sum of 2 consecutive numbers. 2 consecutive numbers means 5 is odd number. So 5 square is what? 25. How you can express 25? You can express 25 as sum of 12 and 13. That means 12 plus 13 gives you 25. Let's discuss another example. Suppose you have to find 13 square. 13 is odd number. So 13 square is what? 69. Now how can you express 13 square is what? 169. How you can express 169? You can express like n square minus 1 by 2 and n square plus 1 by 2. N is what? N is 13. So 13 square is 169. We will get now we can solve it. That means how we can write 169? We can write it like sum of 84 and 85. I think it is clear to you how we can express square of any odd number as sum of 2 consecutive numbers. So let's discuss our next property. Our next property is between squares of two consecutive natural numbers, there are 2n non-perfect square numbers available. So let's discuss this property with the help of example between squares of two consecutive natural number. First of all, we will take two consecutive natural numbers. Suppose I am taking two numbers are 5 and 6. These are the two numbers. So between squares of these numbers, that means between 25 and 36, how many non-perfect square numbers are available? How many non-perfect squares are available between 25 and 36? 2n. N is what? N is 5. This is n, and the next number is n plus 1. This is n. So between 25 and 36, 2n, that means 10 non-perfect squares are available. See how between 25, this is the perfect square of 5, 36, this is the perfect square of 6. So between these two numbers, how many numbers are available which are non-perfect square? 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So see children, we have already find 10 non-perfect squares are available. So these are the 10 numbers which are available between 25 and 36, and all these numbers are non-perfect square. That means these numbers are not the square of any number. So how many non-perfect squares members you can find between two consecutive natural numbers? 2n. Okay, now let's move to next property. Our next property is n plus 1 multiplied by n minus 1. This is n square minus 1. So we will now apply this property. Suppose we are taking two consecutive odd numbers, 7 and 9. These are the two consecutive odd number. How we can write 7? We can express it as 8 minus 1. And how we can write 9? This is 8 plus 1. See, what's the property? N plus 1 multiplied by n minus 1. So in this case, what is n? N is what? N is 8. And how we can find its value? We can find n square minus 1. That means 8 square minus 1, which is 63. So if we multiply 7 by 9, we will get 63. And the another way of finding 63 is what? Express it in this form. N plus 1, n minus 1, and you can apply this formula n square minus 1, and in this way you can find the value. Now let's take two consecutive even number. Suppose 24 and 26. You have to find product of these two consecutive even numbers. How we can write 24? 25 minus 1. And how we can write 26? 25 plus 1. Okay. Now here n is what? 25. N square minus 1. That means 25 square minus 1. So this will be 6